Hey guys, welcome back to series where we are discussing network security for TYBACIT semester 5. In last lecture, we are already done discussing many things. In this particular part, we are going to start discussing with this topic, that is symmetric key cryptography and problem of key distribution. I hope you remember last time we have discussed about symmetric key cryptography and asymmetric key cryptography. What do you mean by this? Let me just revise a bit because that is the most important part for all the further lectures. Symmetric key cryptography, that means we need to use same key for encryption as well as for decryption. To encrypt a message as well as to decrypt the message, we use similar key. When we talk about asymmetric key cryptography, that means we are going to use two different keys. First, while encrypting a message, we are going to use receiver's public key, and receiver is going to decrypt that message using his private key. So in asymmetric key cryptography, we use two different key: public key of receiver for encryption, private key of receiver for decryption. So two different keys are used here, and hence this particular type of cryptographic technique is called as asymmetric. And symmetric means similar key is used for encryption as well as for decryption. Let's start discussing this particular part. When we talk about symmetric key cryptography, there are many problems with respect to this type of cryptographic technique. What are the main problems related to this type of cryptographic technique? One is we are using similar key for encryption as well as for decryption. So when we send our encrypted message, with that encrypted message, either we need to send our key or we are going to send it through some another route. For example, this is my envelope. As you can see in this picture, this is my envelope. So I'm going to send it via air courier, and then key I'm going to send it through some another medium. So in two different mediums, or you can say from two different routes, we are going to send one our message, and second from second route we are going to send our key. But still there are problem, or there are chances that attacker might hack or might get the access of both these things. And if someone got the access of both these things, so he can easily decrypt our message. So this is the main problem. Let's discuss the same scenario here. Why we need two different keys of cryptographic algorithm in a first place? To understand, let's discuss this particular part. As you can see, person A wants to send highly confidential letter to another person, that is person B. A and B both resides in a same city but are separated by few miles, and for some reason cannot meet each other. So let's discuss first case. In first case, as you can see, the simplest solution: A puts the confidential letter in an envelope, seals it and sends it by post. So I'm sealing this particular envelope. That means I'm putting lock on this particular algorithm. So to lock any particular box or any message, to lock it, we need a key. I hope this particular point is clear. Then second, A hopes that no one opens it before it reaches B. But that is not a compulsion. Someone might open your letter before it receives, or before it reaches at destination place. So this solution does not seems to be acceptable. What is the guarantee that our message should be our message goes till receiver without any modification, or no one is going to check? We don't have any assurance for the same. As you can see, there is no guarantee that no person is going to access or no person is going to open your envelope. Sending the envelope by registered post or courier might slightly improve the situation, but will not guarantee that the envelope does not get open before it reaches B. After all, someone can open envelope and read the confidential data and again reseal the envelope. So second is, another option is to send envelope via hand delivery mechanism. Hand delivery mechanism means we are actually going to deliver it. Here A hands the envelope over to another person P, who personally hand delivers the envelope to B. This seems to be a slightly better solution. However, this is also not foolproof. Why? Because there might be chances that P might open the envelope. before he delivers the same envelope to B. Then next part is this solution has here Bob comes up with another idea. So suppose we have two person, Alice and Bob. So Alice is sender, Bob is receiver. So as you can see, Alice sends a message to Bob. So Bob comes up with another idea. What is that idea? This solution has not only prevented unauthorized access to letter but also authorized access. What is this? Let's discuss. Bob now puts the envelope inside a box. This is our box in which our message is sealed or locked. As you can see, lock is here. So Bob now puts the envelope inside a box, seals that box with a highly secure key. We have already discussed in our previous lectures how to use key, and using that key how to encrypt our message. So the same way Bob is also encrypted this particular message or logged this particular message. Since the lock is highly secure, nobody can open the box while in transit, and therefore it is not possible for any third person to open this particular envelope. Consequently, nobody will be able to read or access highly confidential letter. The problem is resolved. If we think about it, we will realize that problem indeed seems to resolved. However, the solution has given birth to a new problem. How on earth can the intended recipient, Alice, now open the box and therefore the envelope as well? So we have only sent this locked box or one envelope encrypted message or logged message we have delivered to Alice. Now remember, we have not sent any key as well with this particular box. So no third person will be able to open it, as well as receiver is also not be able to open it. Why? Because this particular box is locked and we have not shared, or Bob is not shared key with Alice. So as you can see, this solution has not only prevented unauthorized access to a letter but also authorized access, because now Alice is also not be able to open this box. Why? Alice also don't have key to open it. This is, even B would not be able to open the lock. This defeats the purpose of sending the letter in this manner in the first place. So what is another solution? As you can see, now Bob sends locked box or encrypted message with key linked with this. So if someone sends logged message as well as key with that message, then this seems to be very weak idea, because if someone might attempt or might try to hack this particular message, then key is also linked with this particular message. So any one person, any person can easily decrypt this message as well. So as you can see, what if Bob also sends the key of a lock along with the box, so that Alice can open the lock and get access to envelope inside the box and hence the letter as well. This seems absurd. If a key travel with the box, anybody who has access to the box in transit, for example any third person with the name Tom, can also unlock and open the box. Why? Because Bob has sent a encrypted message as well as the key to open this encrypted message along with this box or this message only. So this idea is also not a solution for our problem. What is our problem? Key distribution. When we talk about symmetric key cryptography, so we need to share similar key. The same key we are going to use for encryption as well as for decryption. So if I'm sending message to a receiver, or suppose Alice or Bob is sending message, encrypted message to Alice, that time Bob need to encrypt that message, and same key should be shared with Alice as well. Then only Alice can decrypt that particular message. So here the main problem, the main issue is how to share key. So as you can see, the improved plan. What is the improved plan? Bob will personally go and hand over this key to Alice, and after that they are going to use this particular key for encryption as well as for decryption. So as you can see, read here, Bob now comes up with an improved plan. Bob decides that the locked box should travel to Alice as discussed by post or courier or hand delivery. However, Bob will not send the key used to lock the box along with the box. Instead, Bob will decide a place and time to meet Alice in a person and hand over the key personally to Alice. Now, if we apply just to common sense, if Bob is meeting in person with Alice, then why should he need to send encrypted message via some different medium? He can directly hand over message as well. Why to encrypt and why to decrypt it? He can directly send over, or he can directly hand over message as well. So this is also not a secure plan, because this plan can only work when sender and receiver both are in a same locality, both belongs to same city or same area. Then only this particular plan or this solution is possible. I hope you are getting the main crux behind this. So this now seems to be a foolproof solution. Is it really a foolproof solution? No. If Bob can meet Alice in person to hand over the key, he can well hand the confidential letter as well. Why we need to encrypt the message? So this is the biggest, one of the biggest fool, or one of the weakest plan, you can say. So why have all this additional worry and overhead? Remember that the whole problem started because Alice and Bob cannot for some reason meet in person. That's why they have decided to use some medium to share and receive their messages. When we need to encrypt or decrypt the message, whenever we are not be able to meet with that particular person to whom we need to send some confidential data, if we are not be able to meet with that person if we are not be able to meet that person personally, then only we decide to send an email or send it via some another medium. If we will be able to meet that person in some personal way, then why we need to apply so hectic techniques? Why we need to use some difficult algorithms, right? So as a result, we will observe that no solution is completely acceptable. Either it is not foolproof or is not practically possible. This is the problem of key distribution or key exchange. Remember, this is what we mean by key exchange or key distribution problem, which is linked with asymmetric key cryptography, and hence we came up with an updated version or an actual solution of this type of problem, and the actual solution is called as asymmetric key cryptography, where we use two different keys. So since the sender and receiver will use same key to lock and unlock, this is called symmetric key. We already know about this. Then thus we observe that the key distribution problem is inherently linked with symmetric key operations. Now let us now imagine that only Alice and Bob, but also thousands of people want to send such confidential letters securely to each other. What would happen if they decide to go for symmetric key operation? Then it is very difficult, because if I want to send message to 30 different peoples, then I need to share same key with those 30 or 300 different people. You can just imagine how much traffic it is going to create over a network or over internet. As well as this also decreases the speed of sending and receiving our message. So if we examine this approach more closely, we can see that a big drawback of this particular type of algorithm is if the number of people that want to avail its service is very large, and as the number of people increases, our difficulty also increases. So we will start with a small number and then inspect this scheme for large number of participants. As you can see, for instance, let's assume that A now wants to communicate with two persons, B and C, using symmetric key cryptography. A uses same kind of key, that is a lock for the same property, which can be opened with same key, that is same key for encryption, same key for decryption, and key for sealing the box to be sent to B and C, and same key should be shared with B and C as well. This is not advisable at all. After all, if A uses the same kind of lock and key to seal the boxes addresses for B and C, if A uses same key to encrypt the message which he wants to send to B, as well as A also encrypts message using the same key which he wants to share with C. So if A is using similar key to encrypt both the messages which he wants to send to B and C, then that is also one of the most vulnerable thing. Why? Because we cannot use similar key for encrypting two different messages which we want to share to two different peoples. So what is the guarantee that B does not open the box intended for C, or vice versa? Because B and C would all possess the same key, so it might possible B might hack the messages or communication which is happening between A and C. Even if B and C live in a two extreme corner of the city, A cannot simply take such chances. Therefore, no matter how secure lock and key is, A must use different lock and key pair for B and C. I hope this particular point is clear. So if I want to communicate, or if I want to send message to 3 or 60 or 100 different people, then I need to use 100 different lock and key pairs. I cannot use similar key. If I'm using similar key, that means my messages are already vulnerable. Anyone might attempt to read those messages, or anyone might attempt to hack those messages. This means that A must buy two different lock and key corresponding to two keys, if one key per lock. So as you can see, if A wants to communicate with B only, if there are only two parties, one key. If there are three parties, we need to use three different lock and key pairs. If there are four parties, 6. If there are 5, 10. So you can just imagine, if we talk about 100 different people, then how many numbers of key and pair, lock and key pairs we need to use. So this is too hectic. This is too bulky for practical reasons. So as you can see, if we have about 1,000 persons in a scheme, so we'll have to use 1,000. So as you can see, the total goes to like 4,99,500. This many lock and key pairs we need if we talk about only 1,000 people. So hence this particular technique is not feasible, or you can say this particular technique is practically way more difficult if we have large number of people. For small set of people, we might go for symmetric key cryptography, but for large number of users, this particular technique does not work in a practical manner, and hence we need to use some different things. Now in next lecture, I'll be starting with this particular algorithm, that is Diffie-Hellman key exchange algorithm. So stay tuned. Thank you.